So hey guys, welcome back to another lecture on the limits. In a previous lecture we have discussed what is trigonometry and what is unit circle and how these are useful to find the values over here. So today we're going to discuss something known as limits. What are limits? Like the limits are called as a microscope of the mathematics, right? So these are the microscope of the mathematics. So just limits are just a kind of a something that bounds or restrains. It's just a kind of a bounds like a boundary kind of stuff, boundary kind of thing, or restraints means like a restraint means from here or from here, like etc. We have a limit. So if we have watching a video which is 16 plus, so this is the age limit. This is the age limit. This is the age limit. So like if I wanted to play a PUBG, then it must be like a 18 plus, right? So this is the age limit. This is the age limit. So I just want you to know, like, so if you play PUBG etc. So I just want to give your IDs in the description box below. So I just want to send a friend request and play with you guys and have some fun in the evenings. Okay, so the formal definition of the differentiation will be defined by the limits theorem. So the differentiation is related to the directly related to the limits theorem. So what is a limit are called as a microscope of the mathematics, and this is something like a bounds, like, so I just write that also. This is something like a bounds, just a kind of a boundary, like etc. Okay, just kind of stuff. So we have a, I just want to give an example, like we have a this function. So 1 to x square, right? So if x is equal not equal to 2 and if x is equal to 2, so it doesn't make sense, right? So it's just a piecewise function. It's just a piecewise function, but just as of now just leave it. So you didn't understand like why we are canceling it and why it is equal to, right? So why did these brackets over here and why wait? So I'm going to clearly explain in this lecture. So first we have to know the geometric explanation. So the limit of g of x when x approaches to from both LHS and RHS. So we have a function, right? So we have a function, right? So we have a function like g of x is equal to x square, right? We have a function, right? So we have this function. So the limit of g of x. So the limit of g of x when x approaches to, when x approaches to, which means like it approaching, like it comes from 1.9 and 1.99, and it is closely approaching to 2. Okay, from both LHS and RHS, means like from LHS it is 1.9 and 1.99 etc. From RHS it will become 2.1, 2.11, 2.111 etc. So it is approaching as close as 2. Okay, so if we plot that function as we discussed in our previous lectures, so how we plot that, we see the parabola lecture, you're going to get it. How we plot this? We simply, so after plotting this function which is g of x and x square, we're going to find like the 2 here and the value output is 4. So we just simply plot it and we make a point like this. So this is a g of x parabola, right? So how we find this? So it is approaching, like, so the limit is 2. So the L value, so the I have given example of LHS here. This is LHS. So I'm approaching 2 by step from 1.9, 1.99, from 1.999, 1.999. I'm approaching as close as to the number 2, the value 2. So you can do RHS. So what is RHS? Like 2.1, 2.11, 2.111, 2.1111 etc. So you are approaching as close as to the 2. 2 means like what is going to be the output? X square, which is equal to 4, right? So we're going to get our output as close as to the 4, which is close as to the 4. I hope you're getting it. So when x approaches to, from its LHS is approaching nearly 4. So it from LHS it is nearly 4, right? So 3.996 is almost nearly 4. And from the RHS, which is 2.1, 2.11, 2.111, etc. It is also approaching as close as 4. Then we simply call it as a, then we simply say the limit of LHS, which is negative, is equal to 4, and then E is equal to limit from the positive, which is right hand side, it is equal to also 4, which is the LHS is equal to the RHS, which means like they both close as close as possible to the point, which is 2, right? This is the point of the g of x function. So they both come as close as possible to the point, which is g of x function here, right? So I hope you're getting it. So this is the limit, like, so this is the limit. So this is the limit. So if it means, so it is 18 age, and it is a 17 years, 11 months, 21 days, and then 28 days, and 29 days. You are getting close to the 18, right? You are getting close to as close as to the 18. So to see a movie, right? To see a movie or to play a game. So this is called as a limit. I hope you get it. This is called as a limit. So this is a formal definition of the limit. So the limit of a function, if it exists, the sum of x values, x is c, is the height of the function get closer and closer to the x to c from both LHS and RHS. Means like it coming close from the LHS and from the RHS as close as to the point which is x as to c. So see, it is coming as close as possible to which is like 17 years, 11 months, 31 days, till 31 days night 11.59 time until 12. So here also like 20 years means like 18 years, January 1st at 12.1 second, etc. as close as to this point, which is 18 year age, right? So it is coming from the RHS and it's coming from the LHS. So we simply call it as a limit of g of x if x approach 2. Okay, so the limit, so let f be the function and the c be any real number. So f be the function, so we have a f is equal to function, and c may be 1 or 2 or 3 or 4 or whatever it may be. So 1 or 2 or 3 or whatever it may be. Okay, so we have a f of function. If it is exists, then we have a limit. We have a limit of f of x. We going to cover with the RHS. If x approaches c in right hand side, if it exists from the right hand side, and we have a limit from the left hand side, right? So from the left hand side, so if they both are equal, then we simply call as a RHS is equal to the LHS equal to the RHS as close as possible, right? So it is closing as close as possible to the point which we are giving the function, right? So I just wanted to give a practical example so that you have a better understanding. So we have a function f of x which is y is equal to 3x plus 1. So from that we draw a line. Review the previous lectures, how we draw the line from the previous, how we draw the line from these equation in the, it's not, I hope in the composite functions we have drawn this. I hope in the composite functions we have drawn the how from the equation. So we have a function like limit when x approaches to f of x is equal to 7, right? So how we gonna calculate that? So if we draw a plot, if we draw a line from this equation, the line look like this from the y is equal to this equation, y is equal to 3x plus 1. We simply draw this here, the line look like this. So we just simply plot this value, and the answer is going to be like 7, right? The answer is 7. The f of x is equal to 7. This is the example of the continuous function. If it is continuous, and what is non-continuous, right? So what is non-continuous? Just wait a few minutes, you're going to get it. So I just want to clear with this example. So we have a y is equal to 3x plus 1, right? So we just simply plot this, and we have a pointer which is intersect these 2 and the 7. This is a point which the LHS, which is the limit from x approaches 2 from the left hand side, which is minus, as close as to the 2, and from the RHS also as close as to the 2. Then we simply say this is almost equal. This is almost equal, which is LHS is equal to RHS, and then we simply approve this. We just simply accept this, and we say that the limit of x approaches to f of x is equal to this 7. I hope you're getting it. So just explore it on your own so that you can have a better understanding and a better grip over these limits. Okay, so we have a non-continuous. So as I discussed, right, so as we discussed the continuous function, how this is a continuous function and what is non-continuous function. So I'm going to give an example, like, so this is a piecewise function. So let's say we have a p of x function, and we have a, this is a non-continuous. These are both like limit of p of x. So if we draw a line here, so I just want to give a line. So if we draw a line here, so just ignore that, just ignore these values. If it is here also, right, so if we draw a line from here, from the 3, which is 3 left hand side, and we just plot that, and the value gonna be like similar to the 5, equal to the 5, which is equal to the 5, right? If we draw from the right hand side, then it intersect here and intersect here, which is answer is 3, right? So the LHS, which is limit when x approaches 3 from the left hand side, is not equal to the limit from x approaches the right hand side. Are you getting it? So the LHS is not equal to the RHS. So this is called as a non-continuous function. Means like we are having there are no relationship, we have no any kind of a asymptotes in this graph. Okay, there is a condition like the limit does not exist. So like we have a parabola over here, and this is a vertical asymptotes. What is asymptote? It tells about the idea of the infinity. So like if we have a limit, right, we have a limit of 5, just a 5, just ignore the diagram, it's a 5. Imagine it is a 5, this is a 5.5, just imagine it as a 5. So if we draw a line, it is not touching the parabola, so how we can say that it is related to the parabola? So we just simply call it as infinity. Maybe the value, it may be like 1 2 3 4 5 6 7, it may be like 10 100 1 lakh also. So it is infinity, right? It is infinity, means that there is no limit, which is the limit does not exist here. So the limit does not exist here. I hope you're getting it. So after that, so I hope you getting it why there is no limit if we draw the line here. Maybe with the problem of the equation, right? So maybe with the problem of equation, like we have a y is equal to x square, right? So we should take like a 2x square or 3x square, etc. Okay, so after that we have a continuity. So we have discussed this, right? We have discussed this continuous function. So what is continuous function? I'm going to give a brief introduction over here. So what is continuity? A continuous function is simply a function with no gaps or hole in the middle. So this a function having no gaps, means I didn't lift my pen or pencil until this end of the line, right? Until this end of the line. This is called as a continuous function, means the line which you draw without lifting up the pen or pencil, and that is a continuous function. Otherwise it is a non-continuous function. So I just want to give a better example like this. So I am not lifting my pen here, this is a continuous function. I'm not lifting my pen here also, this is a continuous function. Maybe it may be like this, maybe it may like this, whatever it may be. So it is a continuous function, right? So then what is non-continuous? We are lifting here, so we have a lifting here, we are just stopped here, and we're lifting here, we're lifting our pen. So this gap, it is continuous except this point. This is continuous except, means like the continuous follows from here and it stops here, and then it stops here. So this gap is known as a non-continuous function. We can say that it is not a continuous, it is non-continuous, because we have lifted our pen, right? So after that we have a this example, like we are lifting our pen. So these are not continuous, functions. So I hope you understand that. This is a basic integration of these limits. So I just wanted to recapitulate what I have said. So the limits are called as a microscope of these mathematics, okay, right? So it's just a kind of a bounds and a restraints. It's just a kind of a bounds and restraints or confines, right? So like you may get a doubt, like, so as I said in the first example, like age limit to saw movie, etc. So I have given a formal definition here. So what is, like, how we draw the limits, and what is this point, and how we find, like, as close as possible from the LHS and the RHS, and how we prove that if we say that LHS is accurate, then we're gonna prove it. I have given a beautiful graph example over here, and I have done a piecewise function here. So like p of x function here. So we just simply draw two lines here, which is non-continuous, and we prove like LHS is not equal to the RHS. Then we simply cannot say this is a limit function, right? So if the limit does not exist, then what it might look like. If the limit does not exist, then what the graph look like. So I have given this example, like this is a vertical asymptote, and it is called as infinity. It deals with the idea of infinity, right? So I have covered the continuity. So what is continuous function? So what is continuous, and what is non-continuous here? So tomorrow we going to discuss the limits evaluation, when we going to plug in method, and we have a factorization method, when we have a conjugate method, and we have a speech theorem, which is also called as a sandwich theorem. So I hope you enjoy this lecture. So until then, bye bye, see you in the next lecture.